What happens to the human body if you're exposed to space for just 5 seconds? It's a question that sparks curiosity and fear, imagining ourselves adrift in the vast emptiness beyond Earth. Would we freeze instantly? Explode perhaps? The reality, while still dangerous, is a bit more nuanced. 5 seconds is a shockingly short amount of time, but in the vacuum of space, it's long enough to trigger a cascade of unusual and potentially deadly physiological changes. Let's embark on a journey to understand the profound effects of even the briefest exposure to the harsh environment of outer space. We'll delve into the science, exploring the immediate impacts on the human body and the chances of survival. Join me as we unravel the mysteries of this final frontier, where even a few seconds can make all the difference. Space, unlike our hospitable Earth, is an unforgiving vacuum. It's devoid of the air we breathe, the atmospheric pressure we take for granted. This lack of air pressure is one of the most immediate dangers of space exposure. On Earth, our atmosphere exerts pressure on our bodies, keeping our internal fluids in a delicate balance. However, venture into space and this pressure vanishes. Without that external pressure, the gases dissolved in our bodily fluids like nitrogen would come out of solution, forming potentially deadly bubbles. This phenomenon, known as ebullism, can disrupt blood flow and damage organs. Imagine the sensation of carbonation bubbling within your veins, a dangerous and painful experience. Space is a realm of extreme temperatures. The side facing the sun bakes in scorching heat, while the shadowed side plunges to frigid depths. You might imagine instant freezing or burning, but in just 5 seconds, our bodies wouldn't have enough time to experience the full brunt of these temperature extremes. Our bodies possess a degree of thermal inertia, meaning they resist rapid temperature changes. Think about jumping into a cold pool. It takes time for your body to cool down. Similarly, in the vacuum of space, heat transfer is inefficient. While prolonged exposure would be catastrophic, 5 seconds wouldn't be enough for our bodies to freeze solid or burst into flames. As we learned earlier, the lack of atmospheric pressure in space can cause gases in our blood to form bubbles. This process, called ebullism, is akin to what happens when you open a bottle of soda. The dissolved carbon dioxide forms bubbles as the pressure is released. In the case of space exposure, these bubbles would primarily form in the bloodstream and tissues. While 5 seconds might not be enough time for massive bubble formation, it's still a significant risk. These bubbles can block blood vessels, leading to tissue damage and potentially fatal complications. The areas most vulnerable to ebullism are those with low blood flow, such as the eyes and extremities. Section 5. A race against time. Let's say an astronaut, through some unforeseen circumstance, is exposed to the vacuum of space for a mere 5 seconds. What are their chances of survival? The answer hinges on a race against time and the swiftness of medical intervention. Immediate rescue and recompression are crucial to minimizing the damage caused by ebullism and other effects of space exposure. Medics would work quickly to repressurize the astronaut's body, forcing those dangerous bubbles back into solution. Treatment for potential decompression sickness, similar to what divers experience, would be paramount. While 5 seconds is a terrifyingly short amount of time, it's not necessarily a death sentence. With rapid and appropriate medical care, survival is possible. Section 6. The importance of protection. The potential dangers of even brief exposure to space underscore the crucial role of spacesuits. These technological marvels serve as miniature spacecraft, providing astronauts with breathable air, pressure regulation, and protection from extreme temperatures and radiation. Every layer of a spacesuit serves a vital purpose. The inner layers provide oxygen and regulate pressure, while the outer layers shield against micrometeoroids, solar radiation, and the extreme temperatures of space. Without these suits, venturing outside the safety of a spacecraft would be impossible. Section 7. Beyond 5 seconds. While 5 seconds offers a glimpse into the immediate perils of space, prolonged exposure amplifies the risks exponentially. Without the protection of a spacesuit, the human body would succumb to the combined effects of ebullism, hypoxia, decompression sickness, and extreme temperatures. Organs would swell, tissues would suffer damage, and consciousness would fade. The human body, so resilient on Earth, is ill-equipped to survive the unforgiving environment of space. Our exploration of the cosmos depends on respecting the delicate balance that keeps us alive on our home planet. Section 8. The Final Frontier. As we venture further into the cosmos, the importance of understanding the dangers of space becomes paramount. The human body, adapted for life on Earth, is incredibly fragile when exposed to the harsh realities of space. Yet, it's this very fragility that makes our achievements in space exploration all the more remarkable. We've walked on the moon, sent probes to distant planets, and continue to push the boundaries of human ingenuity. But even as we reach for the stars, we must never forget the vital importance of protection and the delicate balance that makes the final frontier holds endless wonders, but it also demands our utmost respect and caution. If you enjoyed this journey through space, don't forget to like, subscribe, and share this video with your friends. Your support helps us continue exploring the wonders of the universe.